All right, this is Chapter 5, Lesson 8, Factor Linear Expressions. So, a blank is a number, a variable, or a product of a number and one or more variable. In that blank, you're going to write monomial. To blank a number means to write it as a product of its factors. A monomial can be factored using the same method you would use to factor a number. In that blank, you're going to write factor. So, to factor a number means to write it as a product of its factors. A monomial can be factored using the same method you would use to factor a number. The blank 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 of two monomials is the greatest monomial that is a factor of both. In those blanks, you're going to write greatest common factor. So the greatest common factor, or GCF, of two monomials is the greatest monomial that is a factor of both. All right, when I factor linear expressions, I can use the distributive property and work backwards strategy to express a linear expression as a product of its factors. A linear expression is in blank blank when it is expressed as the product of its factors. In those blanks, you're going to write factored form. So a linear expression is in factored form when it is expressed as the product of its factors. So, for example, I have 8x plus 4y. Well, I can take a 4 from 8 and 4 and bring it out front. 4 times the quantity, and then I had 2x plus y. Now, if I were to use distributive property and multiply 4 by 2, I would get 8x. And 4 by y, I would get 4y. So when we're dealing with inverse operations, so addition to subtraction or subtraction to addition, or multiplication to division and then division to multiplication, we also have squares to square roots, but we also have distributive property and factored form. Okay? All right, so my first example, I want to find the GCF of each pair of monomials. So my two monomials are 12CD and 36CD. So what I want to do is I actually want to break them down as much as possible. Now you can use a couple of ways. You can just multiply things. I actually like to use factor trees. Okay, so for example, I have 12CD, right? So 12 I can actually break down into a couple different things. 12 breaks down into 3 times 2, or it breaks down in 3 times 4, or it breaks down into 2 times 6. But I want to break it down into prime numbers. So 12 can be 2 times 6, and then I can break 6 down into 2 times 3. Okay? So 12 CD is the same thing as 2 times 2 times 3 times C times D. Okay? I can do the same thing for 36. When I break that down, I get 2 times 2 times 3 times 3 times C times D. Okay? And then for this, because I'm finding the common factors, whatever they have in common, so they have 2 2's in common, they have a 3 in common, they have a C in common, and a D in common. So my GCF is going to be 2 times 2 times 3 times C times D, or I multiply this together, 2 times 2 is 4 times 3 is 12, so 12CD is my common factor, my GCF, my greatest common factor. So the next thing I want to do is factor 3x plus 9. So method 1, I can use tiles. So I have 3 x's and 9 1's, okay? So I can arrange 3 x tiles and 9 1 tiles into rows and columns, okay? So they want to be equal as much as possible, okay? The rectangle has a width of 3 1 tiles or 3 and a length of 1 x tile and 3 1 tiles or x plus 3. So you can see that I can take out 3 because it's 3. Okay, and if I multiply that through, I'd have x plus 3. Okay, method 2 is to use the GCF. This is actually the method I recommend using. It's probably the least complicated. So again, I'm going to figure out my GCF for 3x and for 9. Well, 3x is 3 times x, and 9 is 3 times 3. Okay. They both have a 3 in common, so that's what I'm taking out. 3 comes out front, and I'm left with an x plus 3. My original expression was 3x plus 9. So I took a 3 from here and I brought it out, and I took a 3 from here and I brought it out. When I multiplied it back through, 3 times x would give me the 3x, and 3 times 3 gives me 9. So when they say they want it in factored form, this is the form that they want it in. Alright, the next one I have says a garden has a total area of 15x plus 18 square feet. Find possible dimensions for the garden. So the first thing I want to do is actually write the prime factorization of 15x and 8. So 15x is 3 times 5 times x, and 18 is 2 times 3 times 3. So the GCF of 15x and 18, they both have a 3 in common. So 3 is their GCF. That's the only thing they have in common. So I'm going to write each term as a product of the GCF and its remaining factors. Okay. When I do that, When I do that, 15x plus 18 equals 3 times 5x plus 3 times 6 equals 3 times 5x plus 6. So the possible dimensions are 3 feet by 5x plus 6 feet. Alright, there are a couple of try problems out below. I want you to go ahead, try them out, and when you're done, we'll go over the answers together. Alright, now that you've had a chance to try out the try problems, let's go over the answers together. So, my GCF, the first one says find the GCF of the pair of monomials 25x and 15xy. So, what I'm going to do is I'm actually going to find my GCF of each of these. I'm going to find my factored form. So the first one I have is 25x. 25 I can break down into 5 times 5. And then 15xy, well 15 is 3 times 5 times x times y, and this one's times x, okay? So I have 25x equals 5 times 5 times x, and 15xy is 3 times 5 times x times y. They both have a 5 in common and an x in common. So that means my GCF is 5x. Number 2 says factor the expression 3x plus 33y. If the expression cannot be factored, right cannot be factored. So I'm going to look at 3x plus 33y, and I'm going to find my prime factorization for 3x, which is 3 times x, and 33y, which is 3 times 11 times y. So 3x is 3 times x, 33y is 3 times 11 times y. So they have a 3 in common, so that's what comes out in front. I'm left with x plus 11y, because that was left here, and that's what was left here. So my answer is 3 times the quantity x plus 11y. I can't combine x and y because they're not like terms. They both have a variable attached to them, but x and y are not the same. Okay, the third problem I have says factor the expression 4x plus 35. So I have 4x plus 35, so I need to come up with a prime factorization. So 4x is 2 times 2 times x, and 35 is 5 times 7. Okay, I can see I have nothing in common, so this cannot be factored. And that is the end of Chapter 5, Lesson 8.